Welcome, everyone. My name is Lindsay King, and I work with the Ministry of Agriculture and Food in British Columbia, Canada. On behalf of the organizing committee, I would like to thank you for joining us. As you can see, I think on that first screen here, this is our third session in our Water Wisdom series, and tonight we're focusing on smart watering, practices for irrigation management. For those of you who haven't been able to join the previous sessions, I'll give you a little bit of background on this North American series. And please, the organizing committee, feel free to jump in if I miss anything. This is the fourth virtual meetup series. BC was invited to this group just last year, so we joined in 2023, but this group started back in 2021. And we are very happy to be included in this series. I believe Mario Miranda Sazo was the initiator of this collaboration, and the intent here is to get growers and researchers together to have more time for an informal discussion so that we can share information and learn from each other. And I'd like to introduce the team now. As you can see on the screen, there are a few of us. We have Daniel Weber from PSU, Emily Lavely from MSU, Caitlin Hengel, my colleague from British Columbia, and we have Christy Grigg McGuffin from OMAFRA in Ontario, Canada, and Mario Miranda Sazo from Cornell, and then Bernadita Salado, who is my co-host today from WSU. As far as session format goes, we are going to start out with two guest speakers today, followed by a grower panel with growers representing regions across North America. So to kick us off, we are lucky to have Dr. Troy Peters and Dr. Victor Blanco with us today. And just a couple housekeeping things. If you have any questions during the presentations, please feel free to put them in the chat. We won't be using that Q&A feature for this session to keep things informal, but we will also have a verbal Q&A after each speaker. So also feel free to keep your questions for that time as well. And again, we really would like to keep this informal, so please feel free to pop comments or questions into the chat at any time, and Daniel will be monitoring that so he can bring those forward after each speaker. So with that, I would like to introduce Dr. Troy Peters. Dr. Peters' research is in the land, air, water resources, and environmental engineering emphasis area. His primary focus is on agricultural irrigation. This includes deficit irrigation, irrigation water hydraulics, irrigation scheduling and management, irrigation automation, sprinkler irrigation efficiency, low energy precision application, low elevation spray application, and crop water use estimation. Troy is located at the Irrigated Agriculture Research and Extension Center in Prosser, Washington, and is also affiliated with the Center for Precision and Automated Agricultural Systems. So thank you, Troy, for joining us tonight, and I'd like to pass it over to you.
Okay, great. So what I wanted to talk about today was irrigation scheduling methods. There's a lot of different ways to know when to irrigate and how much water to apply, basically when to turn it on and how long to leave it on. There's evapotranspiration, or these crop water estimates of which are usually weather-based estimates of crop water use. And then there's an app that we like to promote. It's called Irrigation Scheduler Mobile that helps with that. There's use of soil moisture sensors. And then those usually are broken up into either soil water volume or soil water tension. And then there's sap flow sensors, which measure the flow. It's something that's installed in the trunk of the tree. It measures the flow rate of sap up the tree. It's a velocity measurement that has to then be converted to gallons per tree, which then gets converted to inches of water per day. So it's a surrogate measurement of the inches of water that's used, or how much water is being used per tree per day, and you can use that for irrigation scheduling. There's also trunk diameter sensors, also called dendrometers, that measure the swelling and shrinking of the tree trunk. and that can also be used as a measurement. The most useful measurement that most people use is called the maximum daily shrinkage, and I'll talk a little bit about that. And then there's stem water or leaf water potential measurements, which are pressure bomb readings, or there's these new in situ sensors that can measure stem water potential in the tree or throughout, continuously. So the basics is that soil is a water and nutrient reservoir. It's basically a bucket that can be used to store water and nutrients for the tree and the water gets used up by the tree through evaporation and transpiration. So those together are called evapotranspiration, or ET. So that's the water that comes out of the bucket. The bucket's only so big. If you overflow the bucket, put more water in it than it can hold, the water actually goes out the bottom of the profile. It goes into the soil, but the soil can't hold an infinite amount of water, and the water will continue to go out the bottom of the profile. And that water will be lost, and it's going to take probably soluble nutrients and stuff with it when it does that. So that's not desirable. So in order for us to do irrigation management, we need to know how big this bucket is and how much water is going out, and then we can do an estimate of how much water to put in order to fill it up without overflowing the bucket. The size of the bucket depends on two things, or how much water the soil can hold, the water holding capacity of the soil, and then the root zone water depth. So for good irrigation water management, you have to know three things. So how much water the soil can hold, how much water are you applying when you irrigate, and then how much water per week, or how much water the trees are using. If you don't know that, then it's really difficult to say, okay, I need to leave it on this long, or I need to replace this much. How much water the soil can hold depends on a couple things. So like I said, the water holding capacity of the soil, which in this case, this is if we multiply the water holding capacity of sands, or these different soil textures, by the managed root zone. So most people with tree fruit, they're managing 2.5 to 3 feet deep root zones. Then this is the total inches of water that the soil can hold within that root zone that's readily available. So you can deplete more than these amounts, but the tree is going to begin to experience water stress after you've depleted more than that amount of water. So within the US, if you Google Web Soil Survey, there's the NRCS has data from individual soils all throughout the United States, and you can zoom in on your particular farm. And if you look into the soil physical properties, it'll give you an estimate again of what these numbers are, the water holding capacity. It'll give it to you in different units, like centimeter per centimeter, but you just multiply that number by 12, and that'll give you inches per foot. Then you need to know how much water you're applying, and so that depends on the spacing of your sprinklers or your drip tubing, and how much water is coming out of each one of those emitters per unit of time. And then that will give you a number of either millimeters per day, or centimeters, or inches of water per day, or per hour. I'm sorry, millimeters per hour, or inches of water per hour of runtime. And so we know that people aren't going to do that math, and so we put together a calculator. If you go to irrigation.wsu.edu, there's a calculator on there. If you can enter either your nozzle diameter and the pressure, and that will create an estimate of the flow rate coming out of that nozzle, and then the head spacing, and then the spacing between those lines. And then what a sprinkler efficiency measurement, so it depends on what types of systems you're using, is probably going to be 70 to 80%, and then it'll calculate, and it'll give you an inches of water per hour, and that's a number that's going to be very important to you. It's a number you should write down and keep it in your wallet or something, because it's not going to change unless the pressure or the nozzle sizes change. And that you're going to multiply that by your run times to give you the how much water you're actually applying. And that's really important to compare to how much water the soil can hold and how much water is being used by your orchards. Um, so another way to get that, the flow rates, in this case, you can also, if you know the nozzle flow rate in gallons per minute, there's also, I mean, if you use SI units, you can change these units to liters per hour or liters per minute or however. And then all these units are also can be changed to SI units. Anyway, there's also ways to get those from your particular nozzles. Let's say you don't know what your nozzles are. So if you know what type of sprinkler you're using, you can look this up online. So this is for an R10. So a green nozzle, and let's say we're running at 40 PSI. This will give the flow rate. In this case, it's gallons per minute, 0.46 gallons per minute. And that would get used in this calculator right down here in order to give you your application rate. That's very important for you to go through that exercise, is figuring out what your application rate is. Another way, if you don't want to go through the math, is if you have the designs from whoever designed your system, they shouldn't have that on those designs written somewhere. Here's another simple way. If you have an area and if you know the flow rate onto the area, let's say I'm irrigating 40 acres and I know my flow rate is 80 gallons a minute flowing onto those 40 acres, that'll also give you an application rate. So there's different ways to come at that. And then you compare that to how much water is being used. And so in Wenatchee and Yakima, this is the average, long-term historical average amount of water that's being used by tree fruit per week. And you can see that it changes drastically over the season. And of course, we know that crop water use and crop water needs change drastically. And so it's really important for us to adjust our irrigation schedules in order to accommodate those changes. So if you're and another way to do it is, let's say, oh, I know I'm applying 2 inches of water per irrigation. This will give you the number of days between irrigation events. Just another way to set it up. And then we also, if you're in the state of Washington, at least, we develop tools so you can look up for, let's say your crop is pears and you're in Wenatchee and you're using under tree sprinklers. And and if you'll need to know your irrigation system capacity, and I'll explain that in a minute. It'll calculate your based on an average year, how much time your system should be running. So in other words, based on this particular system, it needs to be turned on and left on the entire months of June, July, and August. However, it needs to be off 1/3 of the time in May and off 2/3 of the time in April. And so you can tell your guys, hey, take a break. September, it should be off half the time. So this is another way to kind of get you in the ballpark. And then again, this will help you come up with your average inches of water per week, that number that you can use for irrigation scheduling. But for that, we need to know what your irrigation system capacity is, basically how much water is being applied per unit runtime. And for this way, there's lots of different ways to calculate this. If you know your flow rate onto a field and the whole field size, like, okay, 40 acres and I'm flowing 80 gallons a minute, this will give me inches of water applied throughout that 40 acres, even though I know I'm irrigating in one place and moving it. I'm one day here, one day here, one day here, but we just ignore that. And because what we're doing with this particular method is we're saying, okay, on the average season, how much time should the system be off? And just to get people in the ballpark is what the idea is with this. So this is the historical average season, and for your particular system, kind of how much time should it be off to get you an idea. And I'll explain a little bit more precise way to do this in the future. I mean, in a few minutes. there's some other ways if there's lots of different ways to know what your irrigation system's capacity is. So get on there and play with that. So basically this is the whole system. Here's the average ET, this yellow line right here. And then the system is on and then off. So basically what the idea is to say, okay, for this particular crop in this particular area, we turn on May 1, we leave it on for a couple weeks. Then we shut it off for a week, and then we turn it on and leave it on throughout that whole until the middle of September, and then we shut it off. And then probably right before the water gets shut off, we turn it on for a little bit of time again. Again, the whole idea is just to kind of get you in the ballpark of when you need to turn on and leave it on. And so this, if the water flowing onto the field pushes the soil water content up, and then ET pulls it down. So early in the season, ET is depleting the soil moisture, we're filling it back up. And then, but if we kept going, we would start overfilling the profile. We'd be losing lots of water, and our newly applied nutrients would all be getting rinsed out of the soil and down into the groundwater. Don't want that to happen. We need to know when to shut it off. It shuts it off. Okay, time to turn it back on. And it turns on, and maybe we should have turned on a little sooner, but we got behind a little bit and then turn off. And again, here, if we would have left it on, we would be exceeding the ET or the crop water use rate. So we shut it off for a little while and turn it on. So this is ignoring kind of where the sets are in a particular block, but it's just kind of on off for the whole season. A better way to do that is keep track of, for a particular spot in the soil, you can use this irrigation scheduler mobile app, which works throughout the West. Lots of different, we've connected it to a lot of different weather systems where it pulls weather data from automatic agricultural weather stations, calculates reference evapotranspiration, multiplies it by crop coefficients, and it comes up with this today's soil water content, and then keeps track of that over the season. So that's for you're irrigating for a particular spot in the soil, but it'll tell you, okay, what is that soil water depletion for that particular area? And I don't really have time to talk about this, except that just Google it, and there's documentation there, and I encourage you to play with it. It's not really an app that you'll find in the App Store. It's a website that you can link. You can put a link to that website on the home screen of your mobile phone, and it'll look and behave like an app because but even though it's operating within a web browser. The other thing we can do is sap flow sensors, and I see that I'm got to speed up here. Sap flow sensors measure the flow of sap up the trunk, and how it usually does that is it has one sensor down here that heats up, and then another sensor that measures temperature. And so it heats up the sap within the trunk, and then that temperature sensor measures the rise of the heat as it comes up from that sensor, and it uses that to create a velocity measurement, or how fast the sap is carrying that heat up the trunk. So the problem with this is it's measuring a velocity, or how a one directional measurement, and then we have to try to get that to gallons, and they usually do that by trying to multiply by the diameter of the trunk, and then we've also got to get that into ET. So the bottom line is this is going to be a relative number, and we have experimented with this the last couple of years with different types of sensors. You can see, so there's the two different sensors. The S2 in this case is a sensor that is in a water stress block. And you can see that it does capture the soil water the plant water use dynamics, and then also the differences between deficit irrigated as well as fully irrigated plants. There we see again, here's the water stressed flows and then the non-water stress flows, and you can definitely see a difference there. However, when we compare this with measurements of ET and the sensors with each other, or different types of sensors, in this case, we compared Dynamax sensors with Treatoscope sensors. Those correlations are they're not bad, but they're not perfect. So here is the correlation with reference evapotranspiration and Treatoscope. So you can see that that those correlations are okay, but not super great. And then we compared the two different sensors with each other, and those were also, I would say, roughly correlated. The other thing that we can do is we can measure the diameter, the shrinking in diameter of the trunk. And so basically this is installed, screwed into the trunk, and then there's a sensor that very sensitive to the shrinking and swelling of the trunk as the water moves through and out of the trunk over time. It expands during the day, and then at night it stops moving. And so this is kind of we can use these and how those diameters change over time. So, and usually what the most commonly used measurement is the difference, maximum daily shrinkage, which is the difference between here and then the highest measurement here and the lowest measurement there. And so this is called MDS versus sap flow. And you can see again that the trunk diameter relationship, and then here's the sap flow. So when we compared the sap flow sensors to this dendrometer, or the measurement of the trunk diameter, again, those correlations were there, but just not great. Sap flow, so yeah, here's another way. But they correlate a little better with the reference evapotranspiration or the weather-based estimates of ET. The other thing we can do, and this was mentioned last time, is measuring the stem water potential using a pressure bomb, where you cut a leaf off and then you stick it within this chamber like this, and it's squeezed around there with a rubber gasket, and it seals around there, and then we increase the temperature within this pressure chamber. And I have no idea why it's called a pressure bomb. Definitely don't call it that if you're taking it through the airport. Call it a stem water potential sensor or something like that. Anyway, you increase the pressure here, and then you're watching this pressure, and when sap starts flowing backwards out of the stem, then the pressure, the suction within the leaf is equal to the pressure inside this chamber, and we can use that to measure the suction within the stem. Doing these, I hope you saw from last time, it's very sensitive to what time of day you take these measurements and how much sunlight they're getting. And so just try to do it the same, no matter, or regardless of how you're doing that. The bottom line is most of these the data is relative. Even the ET-based irrigation scheduling is not. When we compare this to weighing lysimeters or actual direct measurements of the weight of soil and how that changes over time with water coming in and out of it, then they're not all super precise, but it's better than nothing. And especially as you use those numbers and you kind of calibrate them to other measurements of ET, either the look and feel method or the water stress status that you can see in your crops by eye, or then those numbers become more and more relevant to you over time. And because that is important, it's good to, especially soil moisture sensors, if you leave them in the same place and leave them buried, and then you come back and you hopefully last year's experience is informing what those numbers mean to you for this year. And then just gather some sort of data to do your irrigation scheduling, even if it's watching the trees or digging and feeling the soil, just something besides water, just guessing or staying on the same schedule all season, or doing roughly temperature-based irrigation scheduling. You need to do something to get yourself refined on that method, because like we showed, is water use changes drastically throughout the season. It changes with the weather, it changes with crop changes. One block is not necessarily comparable to the other block because of tree density, the age of the trees, the condition of cover crops, the slopes of the fields, all these different things. So you need to kind of alter what you're doing, and hopefully you're taking notes and getting better with this over time. And then I just want to put another plug in there, this irrigation scheduler mobile. As this is ET, or weather-based irrigation scheduling. It's free. It's relatively easy to use. We're trying to make it simple to use. But the only thing is someone has to enter in their irrigation activity. It's not possible for us to know when you irrigate and how much water you apply. And so someone's got to enter that in order for that to work. So, and then just encourage you to play with it and get better over time. Thanks.
Great. Thanks, Dr. Peters. I did get one question in the chat. Folks were wondering if the irrigation scheduler mobile is available to growers outside of Washington, or if that's just a Washington state tool.
No, it works in California, Nevada, Wyoming, Utah, Montana. It even works in Alberta. So
great, thanks.
Yeah.
Any other questions for Dr. Peters? Nope. Okay. Oh, Bernadita?
Yeah, I have one, Troy. So you've been working a lot with growers here in Washington. What would you say is the adoption of this newer technology in the last couple of years? What would you say is the people actually doing today for irrigation?
Yeah, so primarily people still do kind of the methods that they grew up doing, which is the look and feel method, which is fine, and you can get better, you can get good at that over time. And then, but more and more people, especially the more sophisticated growers, are experimenting with dendrometers, with soil moisture sensors, especially because as the communication technologies improve, you can put those systems in the field, and then it's got a telecommunications system where it's talking through the phone system that's got a phone modem on the sensors, and you're getting it on your app on your phone. And there more and more people are playing with that over time. And then usually what they do is they take one, because they're not inexpensive. Well, they all cost different amounts, but they usually pick one block and to irrigate that they're very concerned about, and then they kind of use that to do the rest of the blocks relative to that. Is kind of what I'm seeing.
Thank you.
Okay, thank you very much, Troy. Really appreciate your presentation. Okay, I would now like to introduce Dr. Victor Blanco, who is joining us from Spain. So thanks very much for staying up very late to join us. Dr. Blanco specializes in agricultural engineering and has an MS in Advanced Techniques for Agricultural Alimentary Research and Development. He obtained his PhD in agronomy at the Technical University of Cartagena, Spain, and he was a visiting student researcher at the University of Amsterdam and the Pontificia Universidad Católica de Chile. He then joined Lee Calcett's tree fruit physiology lab at WSU as a postdoc. He has focused his work on the physiological and agronomical response of fruit trees to water stress and environmental conditions, and now is back in his home country of Spain as a researcher for the Institute of Agrifood Research and Technology. So thanks very much for joining us, Victor, and let's see if you can share your screen. Okay, over to you, Victor.
Well, thank you so much. Thank you so much, Lindsay, for your introduction, and thank you to all, and thank you especially to Bernadita for inviting me. Well, today I'm gonna talk about the smart watering, and I think that my talk is gonna be pretty related to the one that Troy has done. So the first thing that I wanted to do was just answering the question, like, what is smart watering? So smart watering or smart irrigation is applying to the crop the amount of water required to obtain the plant water status desired by the grower. So the amount of water that you need to achieve your goal, whatever it is. And you can do that by analyzing the data of the weather, the soil, and the plant. So as a regular idea, the first thing that you want to know always is the water requirements. And it's a good starting point to use the water balance model. This water balance model was developed by Allen et al. And the idea of this model is considering the inputs and outputs. So the inputs here in green as additions are going to be the precipitations and the irrigation, so the water that you are applying to the system, in this case, an apple orchard. And the output or the extractions are going to be the water that is not going to be considered or is not going to be used by the trees, so the drainage and the runoff, and also the changes in the soil water content, and the most important, the evapotranspiration of the tree. The evapotranspiration of the tree here as ETC is going to consider the tree's transpiration and the soil evaporation. So tree transpiration is the amount of water that the tree needs to develop, to grow, and to produce fruit. So that is the concept, that is the variable that we are going to study. So in order to, as I said, to know the ETC, we are going to analyze the data of the weather, so the atmospheric demand, and that's how we can control the air temperature, the rain that we are going to have, the relative humidity, and also with all the data, the sunlight, the speed of the wind, we are going to have the relative evapotranspiration. Also, once we know our atmospheric demand, we also can analyze the soil water availability. So we are going to be able to know how much water do we have, where we have several sensors installed at different depths. We can see if those sensors are installed in the root zone, if the water is available there. But if they are like in areas deeper than where the active roots are, we are going to be able also to measure if we are applying too much water and we are losing that water, because there are not roots that can take that. Moreover, it's not only about installing sensors. We also need to consider the soil properties and the soil texture. And with all that information together, we can analyze the water that is available in the soil. But measuring the weather and the soil is not enough. Even though we can estimate the conditions of the tree, it's always much better if we have some data directly measured with plant sensors, so we can know the tree water status. But as previously, as it has been said, it is really important to know that, because the conditions of the tree are going to change through the season. So the phenology is going to be different and the water needs. It's not the same if the trees are young or mature, the training system, the combination, the rootstock, the crop load, the status, like the nutritional or the health status. So all those conditions are going to change how the tree is working, and also the water requirements. That's why directly measuring the tree can help us to have to have an idea of the real water needs of our trees. So knowing these 3 points, we are going to start with the weather and the atmospheric demand. And we're going to start with that because that is the one that can calculate the reference evapotranspiration, and also because it's the one that is easier to implement. And why it's easier? Because here I also have some data from Washington State, and with the AgWeatherNet, here we can see that there are many weather stations throughout Washington. So you are going to have a weather station close to where your orchard is. So you are going to have good information of the weather conditions, and you can adopt that information to know the atmospheric demand. these values were recorded this morning by AgroWeatherNet, and here you can see that from all these white points, you can assess the different conditions that you have in one part of the states and even in the same county. So once you have selected the weather station that it's closer to your orchard, you can just check the weather conditions there. And here you're gonna have all the variables that I said before, and also for those that irrigate yet based on a calendar basis or phenology, I wanted to highlight also for this month, for the last 10 days, how different the conditions are. So for example, yesterday, June 19th, the maximum temperature was 84 Fahrenheit, while 4 days ago, the 16th, the maximum temperature was 65. So weather, especially in June, in May, can be pretty different within the same week, and it is important to adapt your irrigation to those conditions. Moreover, from all these weather variables, the one that we want to focus is the reference evapotranspiration, here called ETO or ET0, because that's the one that we are gonna use to transform that value into the value or the evapotranspiration of the crop that you want. So this one is calculated according to the weather conditions for a reference crop, in this case, grass, and with this ET0 and a coefficient of the crop, which is the KC here, we are gonna have the real or the crop evapotranspiration. The coefficient of the crop, it's calculated by a weighing lysimeter, and there are some researchers that they have been working on the estimation of this parameter. And here, for example, for apples, we have the evolution of this parameter. So if we know the reference evapotranspiration, and according to this data of the crop coefficient for today, which is the day 180 of the year, the crop coefficient is going to be 0.87. So for the values of reference evapotranspiration and this crop coefficient, we can crop evapotranspiration based on these two parameters, and with information that is available for everybody. So this is pretty easy to adopt, and it's a really straightforward method. If we want to improve this method, we can also measure soil data. And here with soil data, I chose two different sensors, two different parameters. One is soil water content, and the other one is soil matrix potential. These two are commonly used by growers, but they are different. One is focused on the proportion of water in the soil water content. So we are going to measure it with a percentage or a proportion, while the soil matrix potential is going to be related with the energetic state of the water. So it is measured with kilopascals, and it has negative values. So for example, for the soil water content, we generally are going to use sensors that measure the electromagnetic field of the soil, and comparing the amount of water that the soil has, it's going to have the value of all of that. So our values are going to be in a range between 10 when the soil is dry to 30, 40 when we have a soil that is wet under fill capacity conditions. While for the soil matrix potential, values close to minus 10 kilopascals means that the water is available for the tree, it's free, while if these values are much more negative, the soil is drier. So the more negative, the drier is the soil, and values close to minus 80, minus 90 kilopascals can be translated to a severe water stress, or at least water availability that can penalize tree water status. But it is, as I said before, it is not only related with the value that the sensor is measuring, but also the soil acidity, so the texture of the soil. And it is important because if we only have one sensor and our orchard has different soil or different texture, or we have a huge variability, sometimes the same value can be translated in different conditions. So for values that are close to 0.25 of soil water content, if we have a sandy soil, that value is going to be really close to fill capacity. So we are going to have a lot of water available for the trees. While if our soil is not sandy or it's clay, this value is really, really negative. So our trees are going to be really stressed. So it is always good to calibrate your sensors to know those values that, to know the exact value that you have when your soil is full of water or after an irrigation event, and those values that you have when your soil is dry. So knowing those threshold values, if you can refer to the fill capacity and the wilting point, you are going to be able to compare different sensors and different orchards, but not because of the value that is recording, but to the adaptation that you have to do based on your conditions. Here, for example, we have a table for the three values that were represented in the graph, and just to show how different they can be, while the value that they are measuring are pretty similar. And well, the third one, the third point is plant data. And this one is the most important because it's the one that is directly measured in the soil conditions as well as the atmospheric demand. So the integration of those as well as the conditions, the proper conditions, the real conditions of the tree are important in order to tune in the irrigation doses. So here, there are several indicators that can assess tree water status, but the one that we are going to focus more is the water potential because it's the reference one. It is considered for fruit trees and vines, a reference indicator, and it provides information about the flow of the water from the soil to the roots, to the trunk, leaves, and finally to the atmosphere. So just to have an idea of the pathway that the water follows, it goes from values of minus 0.03 megapascals, which is minus 30 kilopascals. So it is free, it is available for the roots, and then it's going to be much more negative as long as it goes through the tree. So we can see how like the changes that we go from the soil to the roots, trunk, stem, leaf, and finally the atmosphere. So these differences are going to help us. They change through the day, but there is always a gradient among them. So always the atmosphere is going to be the most negative and the soil is going to be the less negative. So this pathway is the one that can represent the way that the water has through the tree. Those that, or even we have here a lot of like the leaf and the stem water potential, but also the trunk water potential, which is the one that can be continuously recorded. So just to show some data that was recorded in Washington State last year in Honeycrisp apples grafted on M9, we are gonna show different results in one experiment that was the Smart Orchard, in which we were able to compare under different weather conditions and soil water content, the evolution of different plant sensors. So here, first for the 30 days that I have selected, those days corresponded to the days that we are having this year. So from June the 20th to July the 20th, we had a huge variability of weather with days with maximum temperature close to 100 Fahrenheit, but also days with a temperature close to 80. And similarly, the reference evapotranspiration decreases and increases as the temperature did, and soil water content increased as we apply the irrigation. We did we applied 3 irrigation events. So we were able to see how the trees react to an irrigation drought cycle. Here we are going to show results of 3 trees that we monitorized in the orchard just to check the different results. The first indicator that I'm going to show is the microtensiometer. The microtensiometer measures the water potential or the trunk water potential. So the energetic state of the tree, the good measurement of the microtensiometer is a good indicator to have threshold values, so you can start irrigation when the minimum value of the day is below a threshold value that you can state. Here we observe that for apples, values of -1.5 megapascals were recorded even like when the trees were irrigated, but the days were demanding, but values more negative than -2.5 megapascals were recorded those days where there were no soil available for the roots, so the trees were under severe water stress. Here we can check that, for example, on July 11th, the minimum value recorded was -2.5 megapascals, and that can be a really negative value. Also, we observe how the maximum value of the day, which is recorded at dawn, also was affected and was much more negative when the trees were stressed than when they were irrigated. So here we can easily follow the pattern of the soil water availability and the demand, but adapted to the tree conditions, so adapted to our real trees, not just an estimation. Similarly to the trunk water potential, we also measure the sap flow, and here the results are similar to those that Troy had. The values will follow this pattern. So again, on July the 11th, the trees were days. However, this value as an absolute value can't be used. It is much more recommended to use it as a reference. However, the idea of measuring the sap flow is not to have a threshold value, but to know the volume of water that the trees are using. So it is a really interesting sensor and it can provide a lot of information. However, it needs to be, or we need to work much more with them and develop some sensors that can be easily installed and used by growers. The canopy temperature can be also a good sensor. However, it is strongly related to the air temperature. So it is much better to use, instead of the canopy temperature, the differences between the canopy and the air temperature. So these infrared radiometers are going to measure the temperature of the canopy. And when the temperature of the canopy is 2 degrees above the air temperature, it means that the trees are not transpiring, so they are under water stress conditions. While if the temperature of the canopy is below the air temperature, it means that the trees are able to transpire and they have enough water to grow and to follow the physiological procedures that they have to do. So this sensor can be also a good indicator, however, only if it is compared to the environmental conditions, not as an absolute value. The dendrometers and the diameter variables also follow a pattern which is pretty similar to the values that were recorded with the trunk water potential with the microtensiometers. So the energetic state of the tree was similar to the variations of the diameter. And here we can see how during those days where there is no water available in the soil, the growth of the tree decreases, while when we apply the irrigation, the tree grows. So the pattern of the trunk diameter growth follows a similar idea as the energetic state. And also with the maximum daily shrinkage, which, as Troy said, is the difference between the maximum and the minimum diameter of the day, we can also assess how the stress or how stressed are our trees. So both values are really important. The maximum diameter of the day is going to be recorded at dawn, when, as we previously saw, is when the trees have much more water available, and the minimum value of the diameter is going to be recorded also at midday or early afternoon, the moment where also the minimum trunk water potential was recorded. And the last sensor that I want to talk about is the fruit dendrometer. also because, for example, in apples, the target when we are irrigating are the apples. So it is also important to measure how the apples grow and the dynamic of, or the pattern of growth of the apples, and not only the other indicators that can estimate the growth of the fruit. So here we observe that when we apply the irrigation, also the apples grow much more than the previous day, and how reliable can be this sensor. However, the variability is huge because the position where the apple is, or the size that we have when we start, it's a value that is gonna have a huge impact on the measurements that we are going to have. And to sum up, just as an idea of the sensors that we have, I also wanted to highlight the importance of remote sensing, because as Troy also said, sometimes when we have sensors, we only can monitorize a small amount of trees. So depending on how we choose those trees, we are going to have really different results. So this remote sensing, this idea can be really good to measure the variability that we have. For example, in the orchard that we have, those results that we have been comparing corresponds to this map. So here in the screen, we can see different regions. So depending where our trees are, for the same day, we can have trees that are under no water stress, or that are under water stress conditions. So knowing these patterns within our orchard can help us to select representative trees that are going to help us to monitor the whole orchard. So if we go and we install our trees in an area where the trees are under no water stress, we are going to be aware that those trees that are water stressed are stressed even when those trees that we are monitoring are telling us that they are not. And the opposite, like if we are controlling those trees that are in the area where the trees are water stressed, we should know that if we apply much more water to avoid that water stress in that area, we are going to over-irrigate those trees that are in the blue region. So it is good to have, if we can, different sectors depending on the variability of our orchard. And if we can't, at least we have the information to know that what we are doing is going to have an impact on other regions. So remote sensing combined with trees with sensors is a good idea to manage your whole orchard. And to, as a summary, to sum up, I just want to encourage to use plant sensors, because they provide reliable information and direct information of the tree water status. So they consider all the conditions that we have, and they can help us to know, to have information about our orchards. However, soil and weather conditions can be a good tool and can be easy, maybe more easy to adopt for some growers, and maybe they can feel comfortable. So it is important always to remember that there is no unique solution. So we should know what we want, and we can start with one option and move to another one. So know your orchard and your target. Thank you for your attention.
Thanks, Dr. Blanco. That was very interesting. Does anyone have any questions?
I have lots, but I will make a space for the growers first. So Victor, you mentioned that that picture that you have of the smart orchard, which I know very well, you show that there's this mapping of stress, and one area that you show this that is showing like water stress. How you know that is attributed to lack of water or excess of water?
Thank you. In this case,
Without
just
looking at the image, how could you know if it's one or the other?
Yeah, well, I would say that it is always better if we can consider more than one indicator, but just looking at in this case, what we were checking was the temperature of the canopy, so the crop water stress index, and that index is related with the temperature of the leaves. So it is related with the transpiration. It depends. This index is going to be strongly related with the temperature of the air and the leaves compared to the environmental conditions, but also with some reference trees that you should assess. So if you know the vapor pressure deficit, if your temperature is like, for example, the higher temperature that you are going to have is about 3 Celsius degree above the 3 to 5 air conditions. So that can be directly related with trees underwater stress. However, if you have trees that are like under, well, they have problems with oxygen because they are over irrigated, that problem is you are going to have also that those trees are stressed, but the difference are not going to be in the same range. So if you are really stressed, you are going to be able to detect that. But if you are only a bit stressed, you are not going to be able to check that. You are only going to be able to know that something is happening there.
Okay.
And I saw that Brian turned his camera on. I wonder, Brian, do you have a question or just putting your camera on?
Preparing for the panel.
Well, I guess I kind of have a question.
Perfect.
With all the technology, how does a farmer or a grower apply it? Like, you know what I mean? Like, to make the right decisions and applying that information to utilize it to get the best crop available. How do we, like, where do we start getting that right answer? And that's to either one of Troy or Victor, because like I gather a lot of data on our farm, and I've utilized that data. I've gone to the keep it simple methods because it's time consuming. But I wonder where a new grower, a neophyte basically to this process can use all that information to get the best out of their crop and get the best yields.
Well, I would say that also you can start, like as you said, by something easy that can be easy to adopt. There are a lot of options, and as I said, the best one is the one that it's easier to you, and the one that is not that it's only recording, but you're going to be able to use that information. If you spend a lot of money in sensors, but you don't have the time or you are not able to use that information at some point, it's wasting money. Like, the idea is being able to use that. I would start like being able to recognize the variability of the orchard. In my opinion, that's really important to select those sectors. If you can irrigate them independently, it's great. If not, at least you have that information. You know what can happen, and nobody knows your orchard better than you. But sometimes that information is really good. Also, the soil, like analyzing the soil, the texture of the soil is really important. Sometimes much more than having the sensor and controlling the soil water content is knowing what kind of soil do you have, like the variability that you can expect. And once you really know your conditions, I think that, yeah, you can jump to like soil sensors if you feel comfortable first, just to have an idea of the variability, or you can move to other sensors. But also, it must be said that having this kind of technology, if then you are not going to be able to change your irrigation based on that, that's also a huge thing. Because if you have a threshold value, but then you are not able to start irrigation or stop irrigation when you have that value, well, you're going to have the information, and that's great, but you should know what you have, the cards that you are playing with. So that's also important, to know your orchard and the conditions that you have.
Yeah, my answer is similar in that I would use a combination of a couple different methods ideally. So if I was starting out, I would use ET-based irrigation scheduling that just does water out versus water in, and but sanitize that with at least the look and feel method. So like if example, my ET model says that I should see water stress and I don't, then there's something wrong, and then you adjust that over time. Every sensor, and I definitely shared the frustration, every sensor and different method, there's lots of noise in all of this data, and they all kind of give different numbers which are representative of different things. And so just kind of pick with one and stick with it in terms of, but use one in combination with the other. And one that I would always kind of throw in the mix is again this ET-based irrigation scheduling, just because it's free, but then have some sort of a ground truth, that's based on what's actually happening in the orchard. Like Victor says, the direct measurements of water stress, those are what's actually the tree is experiencing. And so yeah, some sort of ground-based truth, even if it's the look and feel method.
Thank you. I think there's one more question in the chat. Mario, do you want to ask that question yourself, or
anything that Victor or anybody could say about that, about the reduction, about the efficiency of knowing how to use the water, if we can reduce by 20, 25 or 30%, anything related to fruit quality that I think that is what we are trying to learn here, at least in New York, would be highly appreciated. Any comment? Or perhaps for later, for the discussion.
Yeah, so I read your comment, Mario, and that's a great question, especially with young trees, where the goals are different than for mature trees. Where the water is, especially when you compare different irrigation systems like drip irrigation to like under tree sprinklers or over tree sprinklers or whatever you're doing, you have to think about it from the tree standpoint, with what you want to do is, do you want the roots to be looking for water, which means you kind of want to hold it back and then send them looking to spread out, or are you happy with just drip irrigation and making sure that the roots concentrate right underneath that drip emitter? Young trees definitely use less water than mature trees, but not like half as much, because the cover crops are also using quite a bit of water. And so you have to take that into account. Yeah. And in terms of with fruit quality, Victor's probably a little better for answering that part of it and how that interacts with fruit quality, because I'm a general irrigation guy.
There are a lot of regulated deficit irrigation strategies that have been applied. In general, with fruit quality in apples, fruit size is going to be penalized. So depending on which is your target, if you really go to high diameters, that is going to have an impact on the fruit. But if you don't care that much about having apples that are not going to be that big, that can be even good also for the nutritional status of the tree or the physiological incidences. In apples, what has been reported several times is that water stress during the first stages of fruit development are not recommended. So that is the moment where you should be sure that the trees are not under severe water stress. However, in the latest part of the fruit development, if you don't have water, you can also apply some kind of water restrictions, or even if you don't have that much water, you can apply a deficit there, so you can reduce the amount of water during that period. Also, it is, or we should consider that under severe droughts, like for example, now in Spain, we are under a severe drought. It's those trees that are irrigated with drip lines when you don't have water, particularly in apples, because we are using like dwarfing rootstocks and the roots are so concentrated. Those trees are really sensitive to severe droughts. So there are not much more options. Like you should also consider that if your conditions are that you just want to be more sustainable and you want to reduce the water, that's a great idea. But if you have such extreme conditions, also in South Africa or Chile, they were under similar conditions some years ago, those trees are really vulnerable to that. So that's also something to consider.
Okay, thank you. I see Brian has his hand up, but before we go to Brian, I'm just going to pass it over to Bernadita. She'll be leading the panel, so this might be a good time to launch into that. And thanks very much, Troy and Victor. Those are fantastic presentations.
Thank you, Lindsay. Yeah, that's right, because we want to continue with this conversation. I'm gonna just ask our panelists to maybe open the screen and mute yourself, but also invite everyone else that is in this Zoom meeting to contribute and participate in this discussion. So I will start by maybe going around. We have a new panelist from Washington, Paul Carthart, that if you can start by just introducing yourself and your operation and a little bit about your irrigation strategy.
Yeah, my name's Paul Cathcart. I'm an area manager for Columbia Reach and Chihuahua Orchards. So I manage some orchards in Ellensburg and Cowiche, Washington. I manage mostly Honeycrisp orchards, so irrigation is pretty critical to getting a good quality crop on Honeycrisp. Being in Central Washington, we rely on irrigation for practically all of our water. We use an ET-based method for scheduling irrigation, and we use sensors to kind of ground truth that. So in addition to like physically ground truthing it and observing the trees, but the primary scheduling instrument is ET, and then like if our sensors are showing that maybe the trees aren't getting enough water, that could tell me this block maybe has a little bit different crop coefficient potentially than like what's on the weather, or maybe the ET is a little different here than what the weather station's telling me. So then I tend to just adjust the ET by some percentage, like up or down, block by block or valve by valve even sometimes. Like if it's a really low, like a valve that's in a valley, maybe I cut back the ET because there's a lot of natural drainage into there. And so I will apply less water on there just depending on observation.
Thank you, Paul. And I will go back to you about your strategies on Honeycrisp. But before we do that, I would also like to introduce a new panelist, Garrett Herrigers, if I'm correct pronouncing your surname. You can introduce yourself too and tell us where you are from. And I'm hearing that you're wearing two hats today, so if you can explain that a little bit.
Thanks, Bernadita. My name is Garrett Herrigers. You're close enough on that one. I would have probably butchered yours as well. But I'm live in Western Michigan, West Central Michigan. A grower, grow apples, cherries, and asparagus in the sandy soils of West Central Michigan. Emily Labley asked me to be on this today. Somebody couldn't make it previously that had a prior engagement, but so ultimately I also am a crop consultant for Wilbur Ellis Company as well. So I kind of wear, that's the second hat Bernadita was referring to. We grow a few hundred acres of apples and few hundred acres of cherries and a few hundred acres of asparagus, I guess. And of that, we've planting more high density plantings. This area is primarily been a processed market. A lot of that is transitioning to fresh apple production. And with that involves a higher level of management on the irrigation side. We do get blessed with rains, albeit almost too much rain this spring. As a matter of fact, we just recently turned on our irrigation for the first time this last week, whereas we're hitting 90 degrees here, but we've been very wet all spring, again, to the point where we are struggling with foliar disease to this point. But nevertheless, we are dealing with mostly drip, single line drip, very little micro sprinklers in my immediate area. Ultimately, we're using probe schedule that Wilbur Ellis uses to help manage and help schedule our irrigation, but ultimately using the Centec probes to utilize that. A lot of what we do, the management thing, and I think Brian said it best, how do growers utilize all this technology, because I think it's all great and grand, and unfortunately the growers don't have unlimited bandwidth to focus on this one aspect of production. And most growers in my area, for instance, aren't sized to the point where they have the one person to do this task. So this is a tough thing to manage, rather than just kick the dirt, but we have to find a happy medium in between and say, okay, we're going to utilize ET, we're going to utilize you name it, but you got to have enough folks with the bandwidth to do these things. And I agree that that's a difficult thing at times to manage. But yeah, I guess I'm rambling at this point, but yeah, welcome to be part of the team here.
Thank you, Garrett. We also have Molly. Molly, do you want to share about, again, and background on where you are located briefly, as you've been here before in this panel, but maybe just focusing on what type of technology you are using for irrigation?
Great, thanks, Bernadita, and hi everyone again. I'm located in British Columbia with orchards in the Okanagan and Creston Valleys. Our similar situation to what Paul described. We cannot grow without irrigation. It's a very dry climate, and our soils range from sandy loam soils to clay loam soils. So we're utilizing some different methods depending on the block and location. Most of our irrigation is double drip in the cherries with micro sprinklers in other blocks, and some of that is very much dependent on blocks we own versus lease blocks where we inherited systems that came with that block. We do not currently have any overhead irrigation in any of our orchards. We're predominantly cherry orchards, but with the newer plantings in apples and pears, the overhead cooling is something we've very much been considering coming back to. And I'm looking out the window at my old overhead system that we took out, about 15 years ago when we purchased this property, thinking that we would stay only with micro sprinklers. However, with an extended drought and the conditions that we've seen over the last few years, we are changing. So technology-wise, I mean, again, I would say we're not really high tech yet. We've got manual turn-on systems. We do have some automatic systems. We're using ET-based calculations and some soil probes, but we've also tried many different probes over the last few years. We just tried one that seemed really slick that would upload information on both moisture and temperature in the soil to our cell phones, and have had nothing but difficulty with that. So we're trying different technologies and learning as we go. I've mentioned using a lot of cover cropping, but also that all of our new plantings go into plastic, and the drip is underneath the plastic, and we've utilized that as a means of being able to ideally reduce some of the irrigation time and quantity in the first few years of growing, because we're able to maintain a certain level of moisture under that plastic, which has been helpful in our area where we've had significant cutbacks in the last few years. So that's something that we've been trying. We're 3 years into that experiment and, we're learning as we go. There's some other management factors, obviously, to consider there too. But I'll stop there. Thanks again, Bernadita.
May I ask very quickly, what color of plastic you use?
We're using black plastic on the ground. This is similar to what a vegetable grower would be using. We run the drip lines under the plastic at planting and plant into the plastic. But we found that it reduces our herbicide usage, which has been wonderful in our organic blocks, but also in our conventional blocks. And then also just the overall maintenance of the moisture through both the heat dome and the last couple of years of drought. By, we've been able to dial down, like I say, the amount of time and quantity on irrigation and maintain soil moisture. So, but again, not without some drawbacks. There is also the risk of some burning, and too much heat. There's rodent issues and other things that happen under the plastic as well that are not always, preferable. So.
Thank you. Thank you, Molly. And we also have Brian. So Brian, now you can again do a brief introduction, and maybe if you still remember your question, you can go ahead and ask that question.
No problem. Thank you. So I'm located in southwestern Ontario. I am a tender fruit and apple grower here. We're located right on the shores of Lake Erie. Our soil types are fox gravel, which is self-draining gravel, to Brookston clay. So our tender fruits growing up on the gravelly ridges, and our apples and pears are growing a little bit on the clay loams that we have on the farm. The drip irrigation is throughout the whole farm now. There's only the orchards from the 80s that don't have any irrigation on them, any drip. We've been using drip irrigation for quite a while. It's been a trial and error system, but definitely tried some of the technology, found that we were getting too wrapped up in the technology and not maybe feeding our orchards when we should have, and kind of doing that, and went back to the old school methods that I was told to use, which is a graduated cylinder and a cookie sheet. And you time how long it takes for the water to evaporate, and simple little tricks, right? Like Garrett said, it's having that bandwidth, and that was the easiest way to kind of just keep it simple. So yeah, and a shovel. That's my other favorite thing for irrigation. Knowing where that water cone is and what it's doing. So yeah, that's basically us.
Thank you, Brian. And I think that some of you have touched on these pitfalls or challenges with the new technology. And for those of you that have tried different sensors and newer technology, what we think still remains the biggest challenge. And I will start again with you, Paul, because I know you have tried. The first smart orchard actually was in your orchard in Tijuana. And so you have a lot of knowledge with that. What can you share with the growers in terms of challenges with new technology?
I'd say for a lot of like the data-driven technology, the problem is making time to do it. I think Garrett touched on this, which is that growers just have so many things to be concerned about that at times it's hard to make enough time to really dive into some of the stuff. And so I think that's been a challenge for all of us on our team. I think it would really be great to have someone dedicated just to looking at irrigation, who's truly just specialized in that field and has a lot of time to sit there and think on it. But that requires a certain level of scale in your operation that maybe we don't have, maybe many people don't have. So but that being said, like there are certain tools out there that have kind of simplified views that you can get a quick takeaway. And I think the way I've tried to overcome that challenge personally is by trying to identify certain key like metrics that I'm looking for when I go in to look at it. I'm not just like in discovery mode when I'm looking at my sensors. I'm trying to see, like one example is I use soil moisture to see that I'm not driving water through the soil profile, like on sandy soils, for example. So on my sandy sites, I'll be looking at the soil moisture, looking at the 3-foot depth and making sure I'm not spiking my 3-foot depth because I'm running my water for too long. Like that's something that is a specific action that I can take that doesn't take very long that I can do. And then like tools like Phytech, they do have color-coded systems that kind of draw your attention to if anything is apparently in a stressed state. Whether or not how accurate that is up for debate. But it is like a tool that, you know, if I pull it up and everything's green, you know, I might go through and check some other things. But if I see something that's yellow or red, especially, you know, I will definitely make time to sit there and try to figure out why it's in the yellow or red, you know. So yeah, I think just trying to find ways to use the technology in very specific ways allows you to like do things in a more efficient way, I guess.
Excellent. Thank you for that. Does anyone else from the panel want to share some of the tools that you have evaluated in the recent years and what you think it fits better or had made the irrigation scheduling easier? Jared?
Yeah, I mean, we use ProSchedule. I use it. I mean, I know there's a fair amount of folks that use it out west as well. I think the data overload or potential overload is there with that program to be able to see a lot of data, and it's just reading it and disseminating it all to make actionable information out of that. Unfortunately, as we're sitting here, I was going back through on my desktop and looking at some of that, setting some reminders and having it kick then and text my phone and when we drop below a certain moisture, because again, it's not a priority every day for me to do this. It's not top 10 on my priority, maybe because we are getting rain. But if I forget that and forget, oh shoot, I'm a week out on irrigating and it's been 95 degrees and it just slipped my mind. Well, at least I can remember that. Unfortunately, with a lot of the tech stuff, you have to be able to trust it too. So we have some timers and Bluetooth valves and whatnot on a lot of our zones, and unfortunately they don't always work. So you'll go set up a schedule and have everything flow all night, and you go back and you realize 3 zones didn't kick on. Well, then all of a sudden you're trying to disseminate which ones did and which ones didn't, and you're honestly you're there physically anyway. So at that point, why did you spend the money on the valve? You could have just had a PVC valve and turned it and been done. But unfortunately, that's the technology we're dealing with. But I would say overall, as far as management and scheduling and data collection, I mean, I've been happy with my Pro schedule and my Centec Pro. But again, I'm very basic from probably what Paul's doing or what other folks are doing here as well. But it beats a shovel. But I can tell you the shovel thing is still real. Kicking the dirt to see, and the cone's real. Honestly, the first irrigation system we put in, again, we have been used to planting semi-dwarf roots, 106s, 118s, 111s, all big semi-dwarf self-supporting trees, and we get ample rain most times for those. If we got to water them with a tank in the spring to get them started, that happens, but most of the time they go. Then we started planting high density stuff. We realized, okay, we're losing trees. These don't have the root system right to pull this, so we had to adapt. Well, not knowing and what we were doing, honestly, at the point you make those mistakes. You go order drip tube with 24-inch emitters, and you're planting trees at 3 feet, and we're realizing, and most of a lot of what we're planting on is sands with 3-4 CECs, and you just couldn't wet the cone at that point. We're realizing, oh, it's not wet. There might be a tree in the middle of those emitters, and it's not getting anything. So it's just learning those struggles as well as we're going. And we did. I mean, those are hard and fast lessons you learn quickly. That, I mean, you tighten your emitter up, you place things a little better. I mean, all those things. But yeah, from the tech side, I think a lot of it just is trust and distrust, I think, from a few things not working, and you end up doing it the old-fashioned way.
That's right. Yeah, Molly, do you want to add something, or Brian, you want to add something, although you already touched a little bit on these two topics, but
the one thing I found that is interesting is when we started doing the drip irrigation and we started growing the dwarfing rootstocks, because of our soil types and not having the right data, we were over irrigating and drowning our trees very quickly. And it was the opposite to the whole, like, you think you can't over irrigate with drip irrigation, but it made me have to go back to look at soil capacity, figuring out how well the water can move through that soil and the porosity of it. And finding out those little bits of information have made that, like, we stopped over irrigating now. Like, we used to run the irrigation for 4 or 5 hours and think that was great. But now we found, like, from doing that, we found out that, gee, we should actually turn the irrigation off every 2 hours, letting it settle, and then going again. And yeah, so it is an interesting, knowing your soil type and how it behaves to the cultivar and the rootstock that you have is very key to success when it comes to, and I found that even with the pears that we're growing on dwarfing rootstocks. Yeah.
Brian, and just to follow up on that, if I may, so now that so one thing that you mentioned is about assessing the right data, and similar to what Paul was saying, like just targeting to some value that makes sense to you. And how do you define those values, and thinking about in these changes that you have done and learning from excessive irrigation, what do you see that is beneficial for you beside maybe just saving water? Have you seen any other benefits in terms of the fruit quality or the growth of the trees? Or
definitely fruit quality, and definitely on the growth of the trees. Branching, and if you know your trees, if you take a gala tree, you can get branching where you kind of want it. If you take a red delicious tree, the branching is all straight up and down. It doesn't really want to do anything you want it to do. Same with ambrosia. It's funny when you calm that tree down, and almost like, this is where the deficiency irrigation comes in, and that sometimes calms the tree down and makes the tree do what you want it to do better. Whereas if you take gala apples, boy, you can do a lot of things to them, but you over irrigate them and you're done. You will be fighting black rot. You'll be fighting a lot of ambrosia beetle because of ethylene, I think, production. I'm not 100% sure there. I'm trying to prove that one. But yeah, like, you start seeing these oddities, and that's where you kind of start collecting that information. Okay, how long did I irrigate that spot for? And you know what I mean? How many liters did we actually put on? And that's where I say a graduated cylinder throughout the orchard pays off sometimes a little bit better than just the soil moisture, right? Because we've hung all of our irrigation to under our apples and our pears. So that way our water cone is along the whole line. Like, we can make it so that it irrigates the whole row without having just one spot get most of the water. So yeah.
Paul, do you want to share a little bit? You mentioned honeycrisp, that is the high value apple, probably, that we tend to put a little bit more effort in terms of irrigation and irrigation management. Can you share, have you done deficit irrigation? What will be the guidelines that you will think you will follow for honeycrisp?
Yeah, I've done a lot of deficit irrigation. I'd say it's kind of a standard part of our growing program for Honeycrisp. I would say you need to be very careful when you deficit irrigate. It's easy to grow. People are typically concerned with growing too large of Honeycrisp and all the bitter pit and whatnot that's associated with that. And that's definitely a factor, but like, unless you have you need to really look and see, do I have a fruit size issue? If you don't have a fruit size issue and your fruit is where you want it to be, don't deficit irrigate. Just continue irrigating the way you are. If you do have large fruit, then that's when, so like I do a very systematic, like going through every single block of Honeycrisp, taking fruit measurements, and then making deficit irrigation decisions based off of the fruit size in that block. And the reason I'm going to deficit irrigate is that I'm trying to slow the growth rate of the fruit to hit a target size. And so if I don't have large fruit, I don't deficit irrigate. And then depending on how big the fruit is, kind of informs how much deficit I'm going to put on. So like if the fruit's very large, I might go down to 50% of ET, whereas if the fruit is only slightly large, I might do 80% of ET or something like that. So, and word of caution is you can grow very small honeys very easily by overdoing the deficit, and that's not what you want to do. So that's basically it. It's trial and error for me, and just kind of the first year I grew a small crop of honeys the first year I tried it because I just way overdid it. I mean, they were marketable, they were fine, but they were smaller than what we would have liked. So, but the bitter pit does go away. Like if you can control the fruit size, the bitter pit is just not an issue in my experience. So.
And maybe this is but now we got to the end of this session. Again, there's a lot of questions that I still have in table. So I invite you all to join us next week to continue the conversation. But I just want to go back because we have Alan Lax, so that last session he kind of left us very suddenly because of squirrel issues with the connectivity. If Alan, can you comment? Brian mentioned something about ethylene and the stress of the trees. Do you have any information on that, and can you share anything in relation to that?
No, not direct studies where we had the stress and measured ethylene. Although I think ethylene tends to be produced, under stressful conditions. So I wouldn't be surprised if there was a correlation between them. But I don't have any, direct measurements in that. It's an interesting question, but sorry, I don't know. People that work with ethylene tend to not do water stress measurements and vice versa.
The post-harvest and the irrigation go along. And Alan, just to go back to just one comment that we had last week that I think it might be interesting for this session. It was about techniques for when we are in heat stress or conditions of water stress, like sandy soils. What do you think about irrigation in the night? One of our panelists shared that they switched to irrigate in the night and they feel that they have better fruit quality, more an observation that they had. Do you have any comments on that?
No, not direct, primarily because every time I try to do an experiment like that, it rains here.
Come to Washington then.
Yeah, I see some of our colleagues in the East here laughing too. But I mean, there is I guess a hypothesis. Maybe we need someone like Victor to actually test it where he's got the conditions. And that is that because the apple trees have very, very, very weak root systems. I mean, they can be quite long, but they're not dense. And so there's not really very many roots. Compared to, say, a grass cover crop that might have 50 or 200 times as many roots in the same volume of soil. So those few apple roots have to take up a tremendous amount of water because the trees will use, as Troy showed, 90% as much water as a grass with way fewer roots. So we're concerned that those few roots are really sucking so hard in the middle of the day that it's actually drying the soil right around the roots, and that the rest of the soil that doesn't have roots in it has to try to replenish that. And so there's kind of circumstantial evidence that that we're getting a local drying right around the roots. And so that in the middle of the day when you're having really high water use rates. And so one of the things that I'd like to do, but I was never able to get the weather to do it, would be to do different timings and actually measure the stress in the trees. And the concept being that if you irrigated, say, late morning, it depend on your soil how quickly the water would get through the soil to the roots. But you'd want to irrigate, say, late in the morning, so that in the afternoon, when you're having your strongest demand, that your water is getting down onto the roots faster than the soil could normally replace it, and that might help with that stress that's caused by very high evaporation rates in the middle of the day. But
Right.
again, I never had the conditions that I was able to really do that. I think it was Aaron's comment, and I don't know. We're still trying to figure out. We're working on the diurnal patterns of stress and fruit growth, and trying to figure out exactly what's going on there, because we've typically never really looked that closely at a a daily pattern versus like every week or so we'll measure fruit growth.
Right.
So we've still got a lot of work to do, unfortunately.
Well, that's good for us to continue working on these things. So I really thank you all, especially Victor, Blanco, because it's like past maybe 2 a.m. And now you can go out, and probably you will find some bars open in Spain. You wouldn't find
Yeah.
anything open here.
No, I have a lot of ideas now. So thank you,
That's
Alan.
great.
Thank you, everybody. Yeah.
So we welcome you again to join us in the next Thursday, same time. Hope you can make it again, because I think there's a lot of questions that I have for many of you, for Troy, for Alan, if you can continue in this conversation, and of course to our panelists to join us in next week. Thank you so much again, and I hope to see you next week.